Let's continue on with the theme of integration of vector functions here with this example. So particle's acceleration is given by a of t is, let me put a little vector sign over there. A of t is equal to e to the 2t minus 2, t squared minus 1 and 1. I give you here, when t is equal to 1, what the particle's position was and what its velocity was. And I'm asking you to find the position vector as a function of t. Well, what does this have to do with integration? Well, we should know that if you start off with r of t being position, then r prime of t is the velocity of a particle, and r double prime of t is the acceleration of the particle. Two derivatives of position is acceleration. So when I gave you a of t here, really what I gave you was r double prime of t is e to the 2t minus 2, t squared minus 1, and 1. This is really what I gave to you, along with r of 1 and r prime of 1. So r of 1 is 0, 0, 1. R prime of 1 is 2, 0, 0. And so how do we go from acceleration to velocity and position? If you integrate acceleration once, you come up with velocity. If you integrate acceleration twice, you come up with position. So let's go ahead and solve this problem. So for r prime of t, we're going to integrate r double prime of t, e to the 2t minus 2, t squared minus 1 and 1, integrate with respect to t. And we will then have to, so let's find an antiderivative of r double prime of t, and then later we'll figure out the constants by the initial condition here. Okay, so this will be, so the antiderivative, when we integrate e to the 2t minus 2, we end up with, so 1/2 e to the 2t minus 2, because sanity check, so that, the e to the minus 2 there, that will just be a constant. E to the 2t, take the derivative of it, we multiply that by 2, everything checks out. Antiderivative of t squared minus 1, t cubed over 3 minus t, and 1 becomes t, and then plus, so I could just write c vector here, but because we want to solve for c1, c2, and c3, specifically here, let me write this out like this. Okay, so at this point then, the thing is, if we plug in r is equal to 1 here, and we plug in t is equal to 1, r prime of 1, we need to get 2, 0, 0. Okay, so this will be 1/2 e to the 2 times 1 minus 2, 1 cubed over 3 minus 1, and 1, plus c1, c2, c3. And okay, so this is going to be e to the 2 minus 2, e to the 0 is 1, so this is 1/2, and that is negative 2/3, and 1, plus c1, c2, c3 is equal to 2, 0, 0. So what do our constants have to be here? Let's see. 1/2 plus c1 is 2, so this is 3/2. Negative 2/3 plus c2 gives us 0, so this is going to be 2/3. And 1 plus c3 gives us 0, So c3 must be -1. And so then we can put all of this together. What is r prime of t for our particular initial conditions? R prime of t, so 1/2 e to the 2t minus 2, and we said the first constant was 3/2. T cubed over 3 minus t plus the second constant was 2/3, and t minus the third constant plus the third constant was -1. So okay, we have found this particle's velocity. Now we need to integrate one more time the antiderivative of velocity gives you position. Okay, so r of t is going to be the antiderivative. Okay, so 1/2 e to the 2t minus 2 plus 3/2, t cubed over 3 minus t plus 2/3, and t minus 1. We again are going to integrate this component by component. And so the first entry here will become 1/4 e to the 2t minus 2 plus 3/2 t. The second entry here becomes t to the 4th over 12 minus t squared over 2 plus 2/3 t. And then the final entry here is t squared over 2 minus t. And then we need to add on, once again, we need to add on a constant vector here. I'm going to use c1 hat, c2 hat, and c3 hat to distinguish that these constants are likely going to be different than the c1, c2, and c3 that we found in the previous slide. Okay, so r of t is equal to this, and we know that r of 1 is equal to the vector 0, 0, 1. Okay, so r of 1 is, when we plug in 1 up into here, we will get 1/4 e to the 2 minus 2, e to the 0 is 1, so this is going to be 1/4 plus 3/2, and 1/12 minus 1/2 plus 2/3, and 1/2 minus 1 plus c1 hat, c2 hat, c3 hat. This needs to equal 0, 0, 1. Okay, so now we need to figure out what c1 hat, c2 hat, c3 hat are. c1 hat, okay, so 1/4 plus 3/2 is 7/4. 7/4 plus c1 hat is equal to 0, so c1 hat is -7/4. Let's see here, 1/12 minus 1/2 plus 2/3 plus c2 hat will be 0. So c2 hat will be 1/2 minus 2/3 minus 1/12. And so this ends up, common denominator there will be 12. 6 minus 8 minus 1. So that looks like minus 3 over 12 is -1/4. So c2 hat is -1/4. And c3 hat, 1/2 minus 1 is -1/2 plus c3 hat gives us 1. So c3 hat will have to equal 3/2. Okay, and so at the very end of everything, r of t is equal to 1/4 e to the 2t minus 2 plus 3/2 t minus 7/4. T to the 4th over 12 minus t squared over 2 plus 2/3 t minus 1/4. And t squared over 2 minus t plus 3/2. So yeah, I guess this is how you go about answering this kind of question. So if you see this kind of thing, realize acceleration, that's the second derivative of position. Velocity is the first derivative of position. Really, this kind of if I just asked you to, if I just gave you the first components here, I said acceleration at e to the 2t minus 2, and the position at time t is equal to 1 is 0, velocity at time t is equal to 1 is 2. You should have been able to solve that back as a Calculus 1, tail end of Calculus 1 problem. And then it's just basically doing that process of going from acceleration to velocity to position, doing that 3 separate times, once for each component of our vector.